So the next section we're going to look at are analyzing functions. The first two slides in this section are finding the domain and range, which we did in 1.3. So this is actually the same example that we did in the notes for 103. And same thing as this one, it just talks about open or closed circles. So in this section, we're going to look at zeros of a function. So the zeros of a function is when y is equal to 0. So here it says the zeros of a function f of x are all the x values for which f of x is equal to 0. Remember, we said f of x is just a fancy way of saying y. So it's when y is 0, what are our x values? So we just make y 0 and solve for x. So our goal is to solve for x. On a graph, our zeros of the function would be where we cross the x-axis. So it's where y is 0 and we cross the x-axis. Those are our zeros. So zeros, solutions, factors, all mean the same thing. They're all a solution to our function that's given. So example 3, we're finding the zeros. So here we have 3 different functions. So we have to find the zeros for each function. So I change the f of x to be 0, and I solve for x. So here I have a quadratic function. I have that x squared. So I want to factor this. I can't just find 2 factors of 10 that add to 1, since I have a coefficient in front of the x squared. So to factor this, I start by multiplying the first times the last term. So the coefficient of the first times the last. So that would give me negative 30. So now I want to find 2 factors of negative 30 that add to 1. So that would be 6 and 5. So it should be negative 5 since it adds to positive 1. So I write it as x plus 6 and x minus 5. But since we started with a coefficient in front of the x squared that's not 1, since I started by multiplying, I have to make sure I go back in and divide. So I divide both the numbers in my parentheses by that number. So I have x plus 6 divided by 3. If you can simplify, simplify it. So this would be x plus 2. If you can't simplify, that number just goes in front of the x in the parentheses. So this would be 3x minus 5. I can't simplify 5 divided by 3, so I just move the 3 in front of the x. So I just factored it. I still have to find the zeros. So I just set each one of my parentheses equal to 0. So I have x plus 2 equals 0 and 3x minus 5 equals 0. So I just set each one of these equal to 0. In the first one, subtract 2 on both sides. So x is equal to negative 2. In the second one, we add 5. So 3x is equal to 5. Divide by 3. X is equal to 5 over 3. So my 2 zeros of the function are negative 2 and 5 over 3. All right, next let's look at B. So again, I'm going to change the y to be 0. So 0 is equal to the square root of 10 minus x squared. Now I'm still solving for x. I want to find x equals, so I have to undo everything on the right side of my equation. So to get rid of that square root, I'm going to square both sides. 0 squared is just 0. But that square root and the squared will cancel, so now I'm just left with 10 minus x squared on the right. I can add x squared to the other side. So x squared is equal to 10. Next, I want to take the square root of both sides. Anytime you take the square root of both sides of the equation, you have to make sure you include a plus or minus sign. So anytime you take the square root of both sides, your answer has to have a plus or minus. So it would be plus or minus square root 10. We always want to make sure we can simplify the radical. If we can, simplify it. If you can't, just leave it. Our two factors of 10 are 2 and 5. So we don't have any pairs to simplify. So that's as simplified as we can go. So our zeros for this function are positive and negative square root 10. All right, for C, whenever we have a fraction, it's kind of a special case because in a fraction, all we need is the top to be equal to 0, and it makes the whole fraction 0. If I had 0 over 100, that's still 0. So we don't care what value is on the bottom as long as whatever we get for our 0 doesn't make the bottom 0 too, because you can't have 0 in the denominator. So if I had like 100 over 0, this would be undefined. So we don't want 0 in our denominator, we want it in the numerator. So I'm going to set my numerator equal to 0. So 2t minus 3 equals 0. Add 3 to both sides. 2t is equal to 3. And then just divide both sides by 2. So t is equal to 3/2. That's my 0 for this function. In example 4, we did questions like this on the quiz. So use the graphs to describe the increasing, decreasing, or constant behaviors of each function. So looking at A, we're going to assume that these are arrows here. So let's find our interval of increasing first. Moving from left to right, our entire graph is increasing. It's always going up, increasing, increasing, increasing. So we're increasing from negative infinity to infinity. The whole graph is increasing. Remember, when dealing with increasing, decreasing, and constant, we ignore the y value and only look at the x values. Same thing here. For increasing, decreasing, and constant, we ignore the y values and we're just looking at the x values. Again, we can assume that these have arrows here. So our graph would be increasing from negative infinity, and it stops increasing at 1, so where our x value is 1, negative 1. Then we start decreasing. So we're decreasing from negative 1 to 1. And then we start increasing again from 1 to infinity. So we assume that this just goes forever in the up and right direction. So we're increasing from 1 to infinity. So let's start with increasing for C. Again, we can assume that these have arrows here. So we're increasing from negative infinity until we get to this point here, which is 0. So remember, we ignore the values on the y-axis. We only care about the x-axis. We would be decreasing from 2 to infinity. And then we're constant in the middle here, so that would be from 0 to 2. And always, always, always for increasing and constant, we use parentheses. So you never use brackets for these. In the next example, we have relative max and min. So relative max are when we are at like the peak of a mountain. And relative min would be when we're at the valley. Now it has to be decreasing, then increasing to actually be a relative minimum. So you're decreasing, then increasing for a relative min. It has to have that scoop, and it's the lowest point there. Same thing with our relative max. It has to be the top of that mountain. It can't just be like the highest point on our graph. It actually has to have that curve, and the very tippy top would be our relative max. All right, next we're going to look at the average rate of change. Whenever we see average rate of change, it's talking about the slope. They just don't call it the slope because Slope refers to a linear graph. So if I had just a straight line, I could find the slope of the line. Average rate of change can refer to any function. We just need to pick 2 points and find the slope between those 2 points. So we're using the same slope formula that we were using before. So the slope is y2 minus y1 over x2 minus x1. So the slope formula doesn't change. For this example, we want to find the average rate of change of this function from, for a, x is equal to -2 and x is equal to -1. So this tells us our x1 and x2 at the bottom. So x2 is -1, x1 is -2. Now we want to know what our y1 and y2 is. So we're going to use our graph to help us find it. So for our x1, -2, we're going to go to where x is -2, and we see that point down here. We're looking at the y value for when x is -2. So our y1 is also -2 here. We're going to do the same thing for our x2. So we go to our graph, go to where x is -1, so that would be this point here. So our y value when x is -1, so our y2 is 2. So we plug those two numbers in for our y1 and y2. So that would be 2 minus -2, because it's y2 minus y1. Then we just evaluate. So when you subtract a negative, it becomes a plus. So this would be 4 over 1, which is just 4. So our average rate of change between these 2 points would be 4. If it didn't give us the graph, we could always plug our x values into the function here and solve for y. So we would just solve for that f of x. So we would plug it into x here and x here. So let's look at B. We're going to do the same thing. So we have to find the average rate of change from 0 to 1. So again, I use my slope formula, y2 minus y1 over x2 minus x1. It gave me my x1 and x2 already, so I can plug those in. I have 1 minus 0 on the bottom. I have to find my y2 and my y1. So I look at my graph where x is 0, y is also 0. So my y1 is 0. Then I can do the same thing for my x2. So I look at my graph, see where x is 1, y is -2. And then we just solve. So -2 minus 0 is -2. 1 minus 0 is 1. So my slope here, my average rate of change between these 2 points would be -2. Next thing we're going to look at are even and odd functions. So we have an algebraic test that we can do to determine if a function is even or odd. So in an even function, if we plug in -x into all of our x's, so we plug in -x, we're going to end up with the same thing as the original, so same original function. Now if we plug in -x and end up with the opposite original function, so the sign changes in every term of our original function, then it would be an odd function. So the signs change. But every single term, the sign has to change. It can't just be one that became negative. So for both of these, we're plugging in -x. So to determine if this function is even or odd, it kind of told us the answer, but we can ignore that. We want to plug in -x. So I'm going to plug in -x into both of my x's. So -x cubed minus -x. So -x cubed would just be negative x cubed, because if I distribute the cube to both the negative 1 and the x, that negative 1 is going to be negative, because when you cube a negative, two negatives make a positive, but then if you multiply it by another negative, it stays negative. And then this would become plus x. So the signs change in both of our x's, so this would make it an odd function. So this is solving it algebraically. Another way we can solve this, which is kind of like a shortcut way, is to plug in two numbers. So you want to plug in the same number, but it's opposite. And it has to be greater than 1. You can't plug in 1 and negative 1. So the next best thing would be 2 and negative 2. So I'm going to plug in 2 and negative 2. Well, this is G, but I'll call it F. So I plug it into all the x's. So that would give me 2 cubed minus 2. So 2 cubes would be 8. 8 minus 2 is 6. And then we plug in negative 2. So negative 2 cubed minus negative 2. So negative 2 cubed would be negative 8. This turns into plus 2. So that would be negative 6. So when we plug in a number and its opposite, if we get the same answer, then they are even functions. If we get opposite answers, then they are odd functions. And if we get completely different answers, different numbers, then they are neither even nor odd. So here we got opposite answers. We got 6 and negative 6. So this would mean it's an odd function. So the first way kind of looks shorter for this one, but it can be a little bit more confusing when dealing with negatives and making sure all the signs change. So another way, you could either check your work or just do it this way from the start. It's up to you. Would be just to plug in a number and its opposite. So a good number to start with is 2 and negative 2. In some examples, you may see it's easier to plug in a different number, but usually the smaller numbers, the easier the math is. So for B, we can do the shortcut. Let's plug in 2 and negative 2. So I have 2 squared plus 1, which is 4 plus 1, so 5. Negative 2 squared plus 1 would be, negative 2 squared is 4, plus 1 would be 5. So we get the same answer, so these would be even functions. Next, we can also determine if a function is even, odd, or neither just by looking at the graph. So for an even function, our graph is going to be symmetrical about the y-axis. So the y-axis is that vertical one. It would be symmetrical down this axis. So if I had a line going like this on the right side, it would look the exact same on the left side too. So that y-axis acts as our mirror, and we have the same image on the left and the right. If I had an odd function, so the function would be odd if it's symmetrical about the origin. So symmetrical about the origin. So that would mean it's symmetrical on this diagonal line here. So one way you can test if something is odd is by getting the same graph when you flip it upside down. So it'll be the same exact picture. If you take your iPad, flip it upside down, you'll get the same graph that you started with. So So let's take a look at our first example on the left. So if you notice, our graph is not symmetrical about the y-axis because it doesn't have that mirror image on the left and right. It would have to look like that to be the same thing, but it's not. So it's not an even function. We can eliminate even because it's not symmetrical about the y-axis. But next we need to check if it's symmetrical about the origin. So if I take my graph, notice that the right side is pointing up. So the right is pointing up and then the left side is down. If I take my iPad and flip it upside down, my graph now, the right side is still going up and the left side is going down. So this would be symmetrical about the origin. So this is an odd function. So every odd function, you can take your iPad, flip it upside down. If it's the same image, then it's odd. Looking at our next example, we can see that it is symmetrical about the y-axis because we have that same image on the left and right side of the y-axis. So this would be an even function. All right, I'm going to look at 6, 7, and 8 first just to continue with the graphs. So 6, we can see that it's symmetrical about the y-axis, so this would be even. For 7, so we see that the upper left-hand quadrant, so upper left is what goes up. Then in the upper right-hand quadrant, so this is on my right side of the graph, I have this little piece here that's in the right quadrant. And then it goes down to the right. So if I flip this upside down, notice how now this piece is in the left-hand side. So that's now on the left. So that means I don't have the same image when I flip it upside down. So this would be neither odd nor even, so it's either. So because that was on the right side first, when I flipped it upside down, now it's on the left side, I don't have the same exact image when I flip it upside down, so it's neither. All right, let's look at 8. So here I'm pointing to the right in the upper right-hand quadrant, and then left, and it goes down. So if I flip it upside down, it goes to the right in the upper right-hand quadrant, and left goes down, so this would be odd. So we can take a look at number 1. So to determine algebraically if this is an even, odd, or neither function, we want to plug in the same number and its opposite. So I'm going to plug in 2 and -2. So I have x, which x is now 2, so 2 cubed minus 6 times 2. So this would be 8 minus 12, which is -4. And again, we want to plug in -2 and see what we get. So this would be -2 cubed minus 6 times -2. So this is -8 plus 12. So that would be +4. So because these are the same number but opposites, that would make this an odd function.
Hello.
So then we do the same thing for number 2. I can plug in 2 and -2. So I have 2 to the 4th power minus 2 times 2 cubed. So this would be 16 minus 2 times 8, which would be 16 minus 16, so that is 0. Now when I plug in -2, I have -2 to the 4th power minus 2 times 2 cubed. So this would be +16 minus, that's -2, minus 2 times negative 8. So this would be 16 plus 16, which is 32. So since these are different numbers, this would be neither. Now let's look at number 3. This should be x squared. It got cut off on the last page. But we're going to plug in 2 and negative 2. Now again, you can plug in whatever numbers you want. So if I wanted to, I could do 3 and negative 3. That works too. So this would be 2 squared plus 2 times 2 plus 1. So 4 plus 4 plus 1 would be 9. Then I can plug in negative 2. So negative 2 squared plus 2 times negative 2 plus 1. So 4 minus 4 plus 1 would be 1. So these would be different numbers. It is neither. And then we have 2 more. Looking at number 4, I'm going to plug in 2 and negative 2. So 2 squared plus 6 would be 4 plus 6, so 10. And then negative 2 squared plus 6 would be 4 plus 6, 10. These are the same number, so these are even. This is an even function. And then number 5, I'm going to plug in 2 and negative 2. So 2 times 2 cubed plus 7. This would be 2 times 8 plus 7. 16 plus 7 would be 23. Plug in negative 2. I have 2 times negative 2 cubed plus 7. So this would be 2 times negative 8 plus 7. Negative 16 plus 7 would be negative 9. So these are different numbers. So this is, again, neither. So turn in the notes for homework, and then the homework assignment is posted. So you can start the homework if you want, but we'll do it, kind of work together in class tomorrow. I'll give you time in class on Friday, and it'll be due on Monday. So I'll see you guys Friday.